All right, and here we are with vertical axes of revolutions. So this is where we have discs or washers that are going to be horizontal. So we're going to have horizontal ones happening here. So all of these are always going to be done with respect to y. All right, so let's take a look at some of these general ones. If you pay attention, again, we're looking for the big radius, big R, and the little radius, little r. Here we have the y-axis over here, but they're asking us to spin it about the line x equals c, so like x equals 3 or something. So then your radius here is just this distance from here to c, and the little r is the distance from that line c to the function f of y. So you're just subtracting off f of y from c, because again this distance is changing as we follow the function up and down. So you get this equation down here. Again, this is big R minus little r, just like we've been doing all along. Same thing over here. Notice that we are now adding that amount c on here. So it's this distance from f of y to the y-axis plus however far it is over here to c. And down here we can see that same thing happening here. We have big R being the larger distance from the line of axis of revolution to our function here. That's big R, c minus g of y, and then little r is down here, the distance from c to f of y, so it's c minus f of y. And over here, same thing but in reverse. So our radius is getting bigger, and little r is down here. We're adding that c value onto it. So let's try it out here with our example. I drew a sketch of what was happening. We can see the function y equals the cube root of x. It's bounded also by the x-axis, the line x equals 1. So I drew that in. So we're talking about this region right in here that I've sort of shaded in. And we're revolving it about the line x equals 2. So that's this purple line right here that I drew in. So we're taking this region here and we're spinning it about this purple line. So when I'm slicing it up, I'm going to get washers or donuts because I'm going to have a hole in the middle. Some of you might have noticed by now a big tell about whether or not it's going to be a washer is going to be if there's some sort of gap between the region and the line we're going to be revolving it around. That's when you're going to end up with a washer. All right, so here I drew in big R and little r. So we want to go ahead and set up what those equations are going to look like. So we need to make sure they're in terms of y. So this equation right here, I need to solve it for x. So to do that, we're going to have to cube y. All right, so that is going to help us determine big R and little r. So if we start off with big R, our big radius is going to be, here's the y-axis here, so it's our distance from the line of revolution, and then I'm going to subtract off this piece here. So we have 2 minus y cubed. For little r, I'm working with this distance right here, the distance from x equals 2 to x equals 1, which actually is going to stay constant and just always be 1. So 2 minus 1 gives me that distance there for little r. Now we can set up our integration. Volume is equal to pi times, since we're doing this in terms of y, we need to do this with our y values as our bounds. So we're going from 0 up to 1. And we need to have big R, which we said was going to be 2 minus y cubed, radius squared, minus the little radius, which we said was 1 squared, dy. And since we have a picture of a calculator here, you just go ahead and type that into your calculator or Desmos, and we should get that it's going to be 15 pi over 7, which is about 6.7319. And remember, these are volumes, so they're always units cubed. On to the back. Now, I already drew my pictures ahead of time because I figured I'd be less likely to make a mistake that way. All right, so let's take a look here. We've got the parabola y equals x squared. Our other boundaries are the line y equals 4, and we are revolving it about the line x equals 3. So here's x equals 3 over here. Notice I have a gap between my region and my axis I'm going to revolve it about. That tells me this is going to be a washer problem. All right, so let's find our radius. Our outer radius is this distance here. Now, when we have to set this up in terms of y instead of in terms of x, you're actually going to end up with the square root of y, but then that would only give us this half. To get the other half over here, that's actually the negative square root of y. So that's like that plus or minus that we would typically do. All right, it's showing both halves of the parabola. All right, so our outer radius, big R, would be this one right here. And then normally I would subtract off this function, right? But it actually is continuing past this function. So I'm actually going to be doing 3 minus this other function over here. So it's going to be 3 minus negative square root of y. That's kind of different, huh? Little r, the smaller radius, is just like we would normally do. It's 3 minus this function in here, square root of y. All right, so now once we have big R and little r, we can set up our integration. So go ahead and you pause it and you practice setting it up. All right, and hopefully yours looks like mine. Oops, that's supposed to be square root. Square, this one's minus. All right, so you have simplified this as 3 plus square root of y squared, that's that radius squared, minus the little radius, which is 3 minus square root of y squared. All right, so go ahead and compute that. You're going to need to use some generic rectangles to do this one by hand, so go ahead and do that. And then check your work. All right, we get some stuff to cancel out in there. Looks like our 9s. I took the minus sign and I distributed it is what I did. We get the 9s to cancel out and the y's to cancel out. And we're just left with the integral from 0 to 4 of 12 square root of y dy. All right, go ahead and integrate that and see what you get. Oh, I can pull that 12 out, can't I? All right, looks like we're going to end up with 64 pi units cubed. Next example, go ahead and try to sketch the picture and identify the outer and inner radius. All right, so you should have this picture going on here. We have our region in here. Remember, we're doing horizontal slices, so our radius is going horizontally. Big R is going from x equals -2 all the way over here to y equals x. Little r is going from x equals -2 all the way over here to the 2 times square root of x. To be able to do this, we need to put everything in terms of y. So y equals x is fine, but we need to change y equals 2 square root of x in terms of x, and when you get that, you should get 1/4 y squared, because when you divide by the 1/2, then you're going to square after that, so the 1/2 gets squared also. All right, well, let's see, our big R is, let's see, it's this distance from the function x, or y. It's the distance from y to this line 2, so it would be this distance here, which would be y plus the 2. So have the outer radius being y plus 2. Our inner radius is the distance from this function square root of x, which is actually 1/4 y squared. Over here, we're adding 2 to it, so I'm going to have 1/4 y squared plus 2. And the method that we're using is the washer method. Now, because there's going to be a hole in the middle, right? When I slice it up, there's going to be a hole in here. If you wrote these differently, it's possible that you wrote it as -2 minus y and -2 minus 1/4 y squared. If you were following her exact guidelines on the other side, it's fine, because when we square it, everything's going to turn out just peachy. I like thinking of it this way better, but if you wrote it this way, that's fine. So go ahead and set up your integral, work out some math, and turn it on when you need to check. Alright, we got some things to cancel out here, though. When I distribute that negative sign, we're going to get some 4's to cancel, some y squareds to cancel, and so you should end up with the integral from 0 to 4 of, there's a 4y and there's a -1/16 y to the 4th power. When we integrate that, we will get 2y squared minus 1/80th y to the 5th from 0 to 4, and you end up with your volume being 96 pi over 5 units cubed. All right, go ahead and do examples 8, 9, and 10, and then I will have a super short video that will show the answers for those.